Hello students, this is going to be part 3 of this series. We have already covered two parts before. You can check out the videos on the I link above on the top right corner. Okay, so what is this question? Question is, given the identity 2 cos inverse x equals to sine inverse 2x root 1 minus x square. Okay, this is true only if x greater or equals to 1 upon root 2 and lesser or equals to 1. This question also can be asked like this: find the domain of this identity. Okay, this identity only true if x greater or equals to 1 upon root 2 and lesser or equals to 1. Okay, so let's start this. Okay, to start this we will be using the substitution method, and we can put x equals to cos theta. If x equals to cos theta, then what is theta? Theta would be cos inverse x. Okay, theta would be cos inverse x. And now you should know the principal range of cos inverse x. Cos inverse x principal range greater or equals to 0, less or equals to pi. Okay, and cos inverse x means theta. So from here, theta greater or equals to 0, less or equals to pi. We have one condition over here. Next, to prove this, we will be using the simple trigonometric identity, and the identity is sine 2 theta equals to 2 sine theta cos theta. Alright, now we already have x equals to cos theta. It means cos theta we can use x, but sine theta we don't know. But again, there is an identity sine square theta equals to 1 minus cos square theta. Then what is sine theta from here? It is plus minus root over 1 minus cos square theta. Okay, so here plus minus, we will be taking only positive value. Why so? Because theta already given, theta is greater or equals to 0 and lesser or equals to pi. Theta greater or equals to 0, lesser or equals to pi. It means theta either in first quadrant or in second quadrant, and in the first as well as in the second quadrant theta is positive. That's why we will be taking only positive value. Okay, so I hope now this is again clear, no doubt. Okay, we will be taking only positive value. Okay, so 2 sine theta means root over 1 minus cos square theta and cos theta. Now we can put cos theta as x. It is sine 2 theta here, as it is sine 2 theta. Here 2 root over 1 minus cos theta means x. So x is square and this is x. Okay, so we can rewrite properly: 2x root over 1 minus x square. Now we will apply sine inverse on the both sides. So here sine inverse sine 2 theta equals to sine inverse 2x root over 1 minus x square. Okay, now here simple logic: sine inverse and sine can be cancelled only if this angle belongs to the principal range of sine inverse, and sine inverse principal range is minus pi by 2 to plus pi by 2. Okay, so from here what is theta? From here theta is minus greater or equals to minus pi by 4 and lesser equals to pi by 4. This is the second condition over here. It implies 2 theta equals to sine inverse 2x root 1 minus x square, and theta is cos inverse x. It means 2 cos inverse x equals to sine inverse 2x root 1 minus x square. But now what is the theta, restriction of theta? See, from the equation 2 theta follows this condition, and from equation 1 theta follows this condition. So let me check the common values for the theta from equation 1 and 2. Equation 1 says that theta greater or equals to 0, suppose here 0 and here pi. and here theta greater or equals to minus pi by 4. So minus pi by 4 will be somewhat here and plus pi by 4 will be somewhat here. According to equation 2, theta from minus pi by 4 to pi by 4 means theta from here to here. And from equation 1, theta from 0 to pi, it means here to here. So what is the common values of the theta? So common values of the theta is only this part. Okay, it means theta greater or equals to 0 and less or equals to pi by 4. So from equation 1 and 2 we can say that, so theta will be greater or equals to 0 and less or equals to pi. Okay, and theta means cos inverse x greater or equals to 0 and less or equals to pi by 4. Here pi by 4, see pi by 4, no? Pi by 4. And we know that cos inverse x is the decreasing function in the first quadrant. 0 to pi by 4 lies in the first quadrant. So from here I can write x greater or equals to cos pi by 4 less or equals to cos 0. Just apply cos on the all the sides. Okay, then minimum value of cos will be at here and maximum value at here, because theta means cos inverse x is a decreasing function. Cos pi by 4 value is 1 by root 2 and cos 0 is 1. Okay, so we got the restriction on the domain. So domain of the given identity is greater or equals to 1 upon root 2 and less or equals to 1. Thus 2 cos inverse x equals to sine inverse 2x root 1 minus x square whenever x greater or equals to 1 upon root 2 and less or equals to 1. Okay, hence proved.